Welcome to EDU World Space.
We're told we have four different objects. Um, we're told where three of them are located, and we want to figure out where the fourth one should be located so that the center of mass of all four of them is at the origin, or right here. So we're told that the first block, or the first ball or mass, is at the origin itself and has a mass of 5 kilograms. And we're told that the second one here has a mass of 3 kilograms, and it's located at 4 meters up along the y-axis. This one, number 3, has a mass of 4 kilograms and is located 3 meters along the x-axis. And then this one has a mass of 8 kilograms, and we want to know where to put it such that the center of mass of the whole system is at the origin. Well, I've drawn it up here because that's basically positive x and positive y. Now, if we get negative values, we'll know where it is. So I put it up here, although intuition says it should be down here somewhere. And so we should get actually negative value for x and a negative value for y. Now, if we start getting some, we want to figure out what the whole system is. We want to figure out where the center of mass of each of these masses is, and assuming they're uniform, we know that all of these ones, x1 bar and y1 bar, are both 0. x2 bar is 0 because it's on the y-axis here, and y3 bar is 0 because it's on the x-axis. y2 bar is 4, this distance. y3 bar is 3. And so we know that for both the x and the y, the total mass of the system times the center of mass of the system is the sum of the mass of each component times the center of mass of each component. Okay? So in the x direction, we really only have two things that are off of the y-axis that would give us that would shift that has our non-zero x bar, and that's 3 and 4. Okay, so that gives us that. And we want x bar to be 0, so we really don't care what m is, but we want x bar is 0, so we know this thing has to be 0. And same for y, so we take the, in this case, it's just 2 and 4 that we have to worry about. And those two are here, and so again we want this to be 0. Notice that m here could be any mass we wanted, because as long as it's on the origin, then it doesn't come in here because its center of mass is at the origin where we want the center of mass of the system to be. So we just have two equations here and two unknowns, because we know x3 bar and we know y2 bar, and so we can find x4 bar is minus 3 halves, minus 1.5 meters, and y4 bar is minus 1.5 meters. So in fact, it's on the diagonal line here somewhere down in this area where we should put that other mass.